Welcome to the QA Ops channel. Today we are tackling a critical security aspect in continuous integration, secure secret management, and zero trust architectures in Jenkins Groovy pipelines. Hard coding credentials is a fundamental flaw. While Jenkins provides the credentials binding plugin to inject secrets into the environment or with credentials blocks, this built-in masking is not bulletproof. The reality is, if a secret is loaded into the Jenkins worker's environment, a malicious script could still bypass the masking engine by manipulating the string and printing it out. Furthermore, you must never assign retrieved secrets to global Groovy variables. Groovy variables are serialized to disk for pipeline durability, meaning your plaintext token could end up written directly to the Jenkins master's file system. To elevate security, the first step is migrating away from Jenkins to an external secret management solution, such as HashiCorp Vault, AWS Secrets Manager, or Azure Key Vault. By using external Vault plugins, Jenkins dynamically fetches secrets exactly when a pipeline stage runs. This enforces strict access policies and allows for automatic credential rotation. However, even with a vault, the secret is still temporarily injected into the Jenkins pipeline memory space. So, how do we architect a pipeline where Jenkins never handles the secret directly? The ultimate solution is adopting a secretless pipeline execution model using OIDC combined with workload identity. Let's look at the concrete implementation of this secretless architecture by shifting our trust boundary to Amazon Web Services. The traditional anti-pattern is storing the AWS access key ID and secret access key directly in Jenkins. This is a massive security liability. Instead, we can eliminate these static credentials by leveraging AWS IAM Roles. If your Jenkins agents are running as EC2 instances, you simply attach an IAM instance profile to the virtual machine. Alternatively, if you are operating on Elastic Kubernetes Service, you utilize IAM roles for service accounts, which maps AWS permissions directly to your pod. When your Groovy pipeline executes an AWS CLI command or SDK, it doesn't look for Jenkins credentials. It securely queries the AWS instance metadata service. AWS automatically intercepts this and provides short-lived, dynamically rotated session tokens directly to the executing process. Now, let's address a highly advanced enterprise scenario. You have an API token stored in AWS Secrets Manager. You have an IAM role that can fetch it, and your pipeline needs this token to call an external API. How do we ensure this secret is not exposed in logs? And more importantly, how do we guarantee that only one specific pipeline can fetch it? If another developer copies your exact Groovy code into their own pipeline, it must fail. To achieve this architect-level isolation, we rely on OIDC subject claims within our AWS IAM Trust policy. First, we configure Jenkins to act as an OIDC identity provider. When your pipeline requests to assume the AWS IAM role, Jenkins generates a JSON Web Token. Inside this token, Jenkins embeds metadata about the build, including a claim called subject, which contains the exact Jenkins job name. Over in AWS, we modify the trust policy of the IAM role. We add a strict condition block. We use the string equals operator to assert that the incoming JWT subject claim must exactly match the name of our authorized pipeline. If a rogue developer copies your fetch step to a pipeline named Pipeline B, AWS will inspect the JWT, see that the subject claim does not match the authorized pipeline name, and instantly deny the assume role request. The code block becomes entirely useless outside of its designated job. But there is one final attack vector we must close, the Jenkins replay feature. Even if you lock down the IAM role to a specific pipeline name, a developer with replay permissions on that exact job could simply hit the replay button, modify your carefully crafted shell script on the fly, and add a print statement to expose the token in the logs. The first line of defense against this is strict role-based access control. Using the Jenkins Metrics Authorization Strategy or RBAC plugins, you must isolate this pipeline. Ensure that only a highly trusted subset of specific team members is granted the job build and run replay permissions. For the rest of the engineering organization, this job should be strictly read-only or completely hidden. However, For true defense in depth, you should also programmatically police replays within your Jenkins file. At the very beginning of your pipeline, inspect the build causes using the current build.getBuildCauses method. If you detect the replay cause class, you can validate the user triggering the job against a strict whitelist. If an unauthorized user is detected, output a strict security violation print statement to the console and immediately trigger an error to abort the execution. By enforcing this dual layer approach, any attempt to tamper with the pipeline execution via the UI will trigger an automatic failure, ensuring your secret handling logic remains immutable. Finally, to prevent exposing the fetch token during legitimate API calls, execute the fetch and the curl command within a single transient shell session. By using command substitution and turning off shell tracing with set plus x, the secret is held exclusively in the temporary memory of the shell process. It is injected straight into the API request header and immediately discarded when the shell terminates, completely bypassing the Groovy runtime. To summarize, relying solely on Jenkins log masking leaves you vulnerable. Offload your credentials to external vaults. Implement OIDC to drop static keys. Lock down your cloud resources using JWT claims. Restrict execution permissions to designated team members. And always programmatically block unauthorized pipeline replays to ensure your logic cannot be weaponized. Thank you for watching. If you found this architectural breakdown valuable, please subscribe to the QAOps channel and leave a like. See you in the next pipeline execution.